Hello there again, this is Teacher Henry, and today we're going to learn about factoring using difference of two squares. From the name itself, difference meaning the sign between these two terms, these two binomials, will always be negative. And we have for each term a perfect square. So let's have some examples. So let's say for our first example, we have an expression like x squared minus y squared. As I said earlier, the sign between these two terms will always be negative. If in case the sign here will be positive, your answer will be prime, meaning to say it's not factorable. So let's continue with our answer. Okay, how do we answer this difference of two squares? First, we have to put two parentheses here. Now this method is not really hard, for as long as you know how to get the square root of a variable and a constant, or a combination of variable and constant. What do I mean by that? We know that this x squared is a variable. So in order to get the square root of this x squared, all you have to do is to divide the exponent of x, which is 2, by 2. Always by 2. So if we have x squared and then we divide this by 2, the answer is x. We don't write the 1 here anymore because 2 over 2 will give us 1. So we simply say it's x. However, we're going to put the x on both parentheses as the first term of the binomial. Now, since we have a negative here, the sign will always be one positive or negative, or it could be one negative here or one positive, for as long as their signs are different. Let's do it. So let's say this is positive and this is negative. Okay, for the last term here, since we have y squared, we just get the square root again of y squared, or simply factor it out. You say y2, again divided by 2, just like what we did here, will give us y. We don't write the y here anymore because 2 over 2 will give us 1. So we write here y and another y here. And guess what? This is already our answer. Okay, so that is for our first example. Let's have another example, but this time, let's make it a little bit different from the first one. For our second example, let's say we have h squared, this time minus a constant. Okay, let's say 100. Okay, how do we get the factored form of this? Again, we have two parentheses here. Since this is negative, we put one positive here and a negative on the other parentheses. Okay, now we have h squared here. The factored form of that is h. One h here and another h here. So when we multiply this h and h here, it will give us h squared. And again, this time, we are going to get the square root of 100. Later, I'm going to show you, or you can get the square root of the numbers by just thinking of a number and multiply it by itself. So we can say that the square root of 100 is 10, simply because 10 times 10 will give us 100. So we write one 10 here and another 10 here. And again, this is our answer. Now, if we're going to check whether this answer of ours is correct or not, we simply get the product of these, and surely we will have this expression. Okay, so this is our answer for the second example. Now let's have the third example. This time, both terms we're going to put constant and variable, or shall we say, each term will have a numerical coefficient and a literal coefficient. Let's have it. Say we have 16, let's say x squared minus, okay, let's say we have 121 y to the fourth. Now it's quite different. So how do we answer this? Put two parentheses again here. Put one positive here and one negative here. Now, how are we going to answer this problem? First, we have to take the square root of each factor on both terms. Okay, let's follow this. The square root of 16 is 4, simply because 4 times 4 will give us 16. Now, we have x squared. The factored form or the square root of x is nothing but x squared is nothing but x. So we are finished with the first term. Now here, the square root of 121 is 11, meaning to say, when you multiply 11 by itself, it will give us a product of 121. And here, how are we going to handle this? Just imagine y to the fourth, as I said earlier, here and here. In order for us to get the factored form or the square root of y to the fourth, we simply have to divide the exponent always by the number 2. So when we have y 4 over 2 as your exponent, this will give us a value of y squared. And this is what we're going to write here. Now we have finished getting all the square root of each term and each factor. What we're going to do is just to place these numbers and factors on both parentheses. So we have here 4x and 11y squared. And we just have to copy this again. 4x minus, this time it's minus 11y squared. And that will be our answer. Now the last example that I'm going to show you is a little bit different, but it's easy to understand. Let's have it. For the last example, number 4, let's say we have p to the 8. The exponent is 8, and then minus 1. Again, we see that the exponent of p is an even number. For as long as the exponent of the variable is an even number, we can say that that variable is a perfect square. So, for this one, we have p exponent of 8, we have to divide it again by 2, just like what we did here. And then, we have the quotient of 8 divided by 2, which is equal to 4. So, the factored form or the square root of p to the 8 is nothing but p to the 4. However, you will notice this, that the square root of 1 is 1, because 1 times 1 equals 1. So, let's just copy this, positive and negative. This one is p to the 4th. As I mentioned earlier, this is the factored form of p to the 8, or simply the square root of p to the 8. And we copy it here, p to the 4th, and we have 1 here and 1 here, because 1 times 1 will always give us 1. Now you will notice again, the exponent of this variable p is an even number. And this one here is also a perfect square. However, the sign between them is positive, so we can no longer factor them further. However, here, this sign here is negative, that shows the difference. Therefore, this factor can be factored further. And let's do it. Meaning, we're going to factor this as our given. So, just like this, p to the 4th divided by 2 will give us p squared. So we have plus here and minus here. We have to write the p squared here and another p squared here, and then 1, because the factor of 1 will always be 1 times 1. Okay, again, we can now erase this, and the factored form of this is this. And notice again that this is an even number and this is a perfect square. But this cannot be factored further because this is addition. The sign that is present in between the terms is positive, therefore we cannot factor it. However, the other factor of this binomial is p squared minus 1. So this is difference, and we have a perfect square here and a perfect square here. The factored form of p squared minus 1 will be p plus 1 and p minus 1. Because p squared, just like this one, will have a factored form or square root of p and another p here. So, we have the solution here, and we're going to finalize, or we're going to write the final answer for this problem. We have now, we're going to copy this as your first factor, p to the 4th plus 1. Okay, now remember, we factored this, which is the factor of this binomial. So the answer to this, or the factor form of this, will be this expression or this factor. So we have here p squared plus 1 and another. We're not going to write this anymore. Instead, the factor form of this binomial. So we have now p plus 1 and we have p minus 1. And this, my friend, will be the final answer for this expression p to the 8 minus 1. And this is the factored form. Final answer for the expression p to the 8 minus 1 would be p to the 4th plus 1 multiplied by the binomial p squared plus 1 multiplied by the binomial p plus 1 and p minus 1. In other words, we have 4 factors and each factor is a binomial. Now to summarize, you will notice that all my given problems are expression of difference. And at the same time, we have variables and constants that are perfect square. So, for us to know whether the variable is a perfect square, just remember that its exponent should always be an even number. And when that happens, all you have to do is to divide the exponent of the variable by 2. Always by 2. What about for constant? For constant, you simply find the square root of that number. Let's say 100, the square root of 100 is 10. That's why we have 2 tens here. The square root of 121 is 11. 11 times 11 will give us 121. That's why we have 2 11s here. And so on and so forth. So for this type of factoring, I hope you learned something from this video. And I'll see you again for my next video in the succeeding lesson. Once again, this is Teacher Henry saying, study hard and be good. Thank you so much.